The non-avian dinosaurs were one of the most infamous and successful groups of animals to ever live, responsible for producing the largest terrestrial carnivores and herbivores of all time. While size certainly goes a long way in nature, they were also extremely diverse in their tools and weaponry, all of which helped them to establish one of the longest reigns known to paleontology. This reign lasted for over 150 million years and led some to dedicate an entire geological era to them, as the Mesozoic, which covers the Triassic, Jurassic, and Cretaceous periods, is often nicknamed the Age of Dinosaurs. And yet there was actually a time during this era, specifically the Triassic period, when the Earth was not ruled by dinosaurs. For a portion of it, they hadn't yet evolved, and then even once they did, they had to endure millions of years of living in the shadow of another group, just as mammals later had to live in the shadow of dinosaurs. It was during the Triassic that a notorious group of predators emerged who pushed the limits of ferocity and are the only animals known to have generally dominated the non-avian dinosaurs in every environment that they shared. These were the Rauisuchians. Ironically, they happen to belong to the exact same taxonomic clade that dinosaurs fall under, Archosauria. But instead of being part of the division that includes birds and their extinct non-avian dinosaur relatives of Emetotarsalia, they instead belong to the Pseudosaucia, which includes crocodilians and their extinct relatives. It is believed the Rauisuchians first emerged some 249 million years ago, during the early Triassic, and the group in its broader traditional sense currently consists of approximately 39 different genera. These are generally defined as Triassic Pseudosaucians that were usually extremely large, predatory, and quadrupedal, though many exceptions to these general rules exist. Today, the grouping Rauisuchia is often described by scientists as being informal, meaning it's likely paraphyletic, not containing all descendants of a common ancestor, rather than a well-defined, natural, monophyletic group. But what is well-defined is that these creatures were quite formidable. Out of every land predator to ever emerge, it was they who came closest in size to rivaling the immense statures seen in giant theropod dinosaurs, with most of them having fallen between 4 to 6 meters, 13 to 20 feet in length, comparable to the size of giant crocodiles. Many got even larger than this, with some like Pastosuchus, arguably the most famous of the bunch, breaking 7 meters 23 feet, rendering it the largest predator within its specific environment. Somehow even it was outsized by certain relatives such as Saurosuchus and Prestosuchus, who could both reach around 5 meters 25 feet, which already makes them bigger than all known terrestrial mammalian carnivores, alive or extinct. Thanks to these sizes, Rauisuchians, in this broad sense, were almost always the largest threats one could find in a Triassic setting, and were well beyond the size of any known contemporary predatory dinosaur. In a few places, they happen to be the largest megafauna, outright a trend. Especially common towards the early Triassic, when large herbivores were rarer, a consequence of the giant Permian-Triassic extinction event that had taken place just prior. Funnily enough, though, it was only when some Rauisuchians lost the title of being the absolute largest animals in their environment due to the rise of giant herbivorous dinosaurs that perhaps the biggest predatory member of their lineage came to be. This creature also happens to retain the title of one of the largest non-dinosaurian terrestrial predators to ever walk the earth, Phaseolosuchus. This behemoth of a Rauisuchian hailed from northwestern Argentina, where during the Norian stage of the late Triassic, it terrorized the lands with its monstrous size. Even the smaller specimens, believed to belong to this genus, were thought to have been larger than almost every other Rauisuchian, while the larger individuals were on a whole other level, as they possibly grew to be 3.1 tons in weight and 10 meters 33 feet long, literally bigger than some of the most famous large theropods known from later periods, like Gorgosaurus, Majungasaurus, and Carnotaurus, just to name a few. I should also mention that with these stats, Phaseolosuchus was not only far bigger than any terrestrial predator conjured up by mammals, but indeed larger than nearly every other terrestrial carnivore to arise in general after the extinction of the non-avian dinosaurs. The largest Cenozoic terrestrial predator, Rauisuchians, a Rauisuchian crocodilomorph, was only a bit over half the estimated weight of Rauisuchians. So you can bet that with this size, almost everything in its environment deferred to it, including a variety of contemporary dinosaurs, like Coloratosaurus and Zupisaurus. By this point, dinosaurs had already been on the scene for roughly 13 million years, and while they weren't the rulers yet, they had undergone impressive diversification. This included the evolution of early sauropodomorphs, who perhaps unsurprisingly became prey for Rauisuchians. Namely, it is believed that Lesimsaurus, one of the most basal large sauropodomorphs, was one of the main food items for Rauisuchians, and might have been a partial reason behind its hunter's immense size, since Lesimsaurus itself was also quite the behemoth, with individuals estimated to weigh around 7 tons. As we know, access to large prey usually means the potential for seriously big predators to evolve. Unfortunately for Lesimsaurus, the threat of a Rauisuchians would have emerged relatively quickly, as studies on the bones of this Rauisuchian suggest rapid growth rates, a trait often seen in other Rauisuchians as well. Their growth patterns were actually, in some cases, typically faster than what was seen in contemporary dinosaurs, just giving them another potential advantage. Now, to actually take down a large sauropodomorph, paleontologists believe Rauisuchians would have utilized its titanic skull, which alone was about the size of a person, and not to mention filled with very large, sharp teeth. It likely used these to rip off huge amounts of flesh, leading to rapid blood loss and shock in its victims. These teeth are also what made Rauisuchians, in general, such tough adversaries for early dinosaurs, even if they weren't all 3-ton giants. Their teeth designs were often unusually long, extremely sharp, and a bit curved, allowing them to act somewhat like sabers and dish out a crazy amount of damage with minimal applied force. This is perhaps best demonstrated by Saurosuchus, one of the biggest Rauisuchians and also one of the better studied ones. Of course, in typical Rauisuchian fashion, it had a giant head about the length of a medium-sized dog. Yet recent research on its bite uncovered that it was actually relatively weak for its size, as in perhaps only as strong as the bite of a modern gharial, which is not only smaller, but also specialized in catching fish, not crushing or tearing large terrestrial prey. However, because the teeth of Saurosuchus were just so well adapted for cutting, scientists still think that it was an undisputed apex predator. It likely hunted large-bodied prey by shearing off chunks of flesh, with the only real drawback being that it might have had to leave some meat on the bones, which proved too hard to reach or process. Now, while it is likely that at least some of the other Rauisuchians also had a relatively weaker bite force for their skull size compared to later giant theropods, not everyone is convinced that all Rauisuchians had universally weak jaws. The emerging idea is that each type had a pretty different kind of dentition and skull mechanics, allowing the broader group to develop a variety of feeding techniques, with some being able to shred large, tough prey, while others went for vulnerable, softer or smaller animals. This range is what led to them preying on virtually every kind of suitable animal the Triassic offered, which in addition to dinosaurs at certain points included dicynodonts, non-archosaur reptiles, and even other pseudosuchians, despite occasionally being divided by the functions of their teeth and preferred prey. What did unite the vast majority of typical Rauisuchians was another advantage they held over many Triassic dinosaurs' armor. Like their distant descendants today, the crocodilians' many Rauisuchians sported osteoderms across their bodies. These were bony deposits that formed mainly in plates within the skin and were typically positioned along their backs, necks, and sometimes above and under the tail. Compared to other animals with osteoderms, Rauisuchians often had some pretty thick ones, in some cases even thicker than what's seen in modern crocodiles. This might seem like overkill, since crocodile osteoderms themselves are known to already be highly resistant to cuts, slashes, and abrasions. Furthermore, Rauisuchian osteoderms could either be arranged in 1 or 2 rows and were oddly not always symmetrical, perhaps in order to give each individual a unique appearance for social identification or display purposes. What's more, in this group armor came in various shapes and sizes, with some like Prestosuchus sporting osteoderms that were somewhat heart-shaped of all things. But let me tell you, these were not for spreading love. Their main purpose, of course, was defense. Since these creatures were already often the kings in their environments, it's hypothesized that the osteoderms weren't primarily a deterrent for coexisting dinosaurs or other smaller archosaurs, but rather for competing Rauisuchians during intraspecific combat. This would also make sense considering that the osteoderms were concentrated on the top of their bodies. Given their size, these areas were largely inaccessible to most other contemporary predators, with the notable exception of other large Rauisuchians. However, not every Rauisuchian had the luxury of heavy armor. A small handful opted for just tough skin, with one of them being Rauisuchians, a relatively smaller member that lived in what is today Argentina, not China, and might not have needed as much armor due to a relatively nimble skeletal structure that provided it agility and speed. Another Rauisuchian often cited for unique features was Arizonosaurus, who, as you can probably guess, lived in Arizona. When you take a look at this archosaur, the potential lack of extensive osteoderms compared to some others is probably not what you first notice, but rather its prominent sail-like structure along its back. Yes, just like some dinosaurs, e.g. Spinosaurus and other earlier synapsids, e.g. Dimetrodon, while Pseudosaucians also evolved sails. This is a fascinating case of convergent evolution that might have occurred due to the hot temperatures seen in the Triassic, with global average temperatures being significantly warmer than today, and therefore it is believed that the sail could have aided in thermoregulation. Arizonosaurus wasn't entirely unique among its close relatives in having elongated neural spines. Other Titanosauriskids also displayed this feature. Of course, thermoregulation may not have been the only purpose behind these sails, with another popular idea being that they were used for social display. While these biological structures definitely made them quite a funky bunch. Among Pseudosaucians, they definitely were not alone in their weirdness. You also had genera like Tyrannosaurs, which had no sail but was semi-aquatic. In fact, it's one of the few Pseudosaucians from that time, outside the direct crocodilian line, thought to be significantly adapted to water. Despite many Rauisuchians looking superficially like giant terrestrial crocodiles. Tail remains belonging to Rauisuchians show that it had a laterally compressed tail and tall neural spines, which indicates powerful aquatic propulsion. Other water-friendly adaptations included potentially reduced dermal armor compared to heavily armored terrestrial forms and an elongated neck, perhaps for catching fish. Yet it still retained unspecialized legs, suggesting that if it wanted to, it could still very much walk effectively on land. Thankfully, for any vacationing time travelers wanting a freshwater dip, it was not typically the biggest predator out there in those specific aquatic environments. And it didn't generally bother with deep freshwater sources, instead, likely inhabiting shallow rivers and lakes of the time, making it somewhat analogous in lifestyle, though not closely related to another staple of the Triassic, the marine reptile Nothosaurus. Despite its croc-like appearance, Nothosaurus was not a Rauisuchian or even a Pseudosaucian. But it again brings to light how this broader period seemed to foster a superpower for convergent evolution among reptiles. This wasn't even the most striking case of convergence related to the Pseudosaucian lineage, as ironically, there were actually some Pseudosaucians that evolved features making them resemble those who lived in their shadows, the theropod dinosaurs. Now remember what I said about Rauisuchians usually being quadrupedal. Well, like I said, there are exceptions. And some Pseudosaucians, often outside strict Rauisuchia, decided to break that general rule with a few developing bipedal locomotion, as seen in forms like Shuvosaurus ephigia and Poposaurus. It wasn't just walking on two legs that made them superficially theropod-like. These genera typically had reduced forelimbs, dinosaur-like hips, in terms of obligate bipedalism and skull structures that were surprisingly similar to certain theropods like ornithomimids. in the case of Shuvosaurids, making it not so hard to see why for a while paleontologists thought some of them were actually theropods. Yet of course we now know that they weren't due to features like their cruritarsal, crocodile-normal ankles and other skeletal details distinguishing them as pseudoreuchians. Interestingly enough, none of these true theropod lookalikes like Shuvosaurids actually coexisted with the most advanced large dinosaurs. Instead, they often shared environments with more primitive dinosauriforms or early dinosaurs, who could though also be bipedal. In true Rauisuchian, or broader pseudoreuchian predator fashion, it was also some of their quadrupedal members that became the closest non-dinosaurian bipedal analogues in general form. In size to what giant theropods would later achieve, though, the largest pseudoreuchian bipeds were smaller than the largest quadrupedal Rauisuchians. Now, not all of the bipedal pseudoreuchians were massive. Ephigia and Poposaurus were on the smaller to medium side. But Silosuchus, a related Shuvosaurid, was a larger biped, though perhaps not rivaling the 10-meter length of Phasolosuchus. The script's reference to a 10-meter bipedal Silosuchus is very large for this group, while potentially reaching impressive lengths for a bipedal pseudoreuchian. It wouldn't have been nearly as heavy as the giant quadrupedal Rauisuchians due to a lighter skeletal build, with estimates giving it a weight more in the range of hundreds of kilograms rather than multiple tons. Furthermore, it wasn't the meanest hunter around either, as it broke another typical Rauisuchian predatory pseudoreuchian rule: its diet. Because as opposed to most large pseudoreuchians that were hypercarnivores, creatures like Silosuchus and Ephigia were actually likely herbivores, or omnivores having a toothless beak that allowed them to shear leaves off trees or process other plant matter. They weren't the only leaf eaters either, since other bipedal genera like Ephigia were certainly not hypercarnivores. Poposaurus, on the other hand, was still very much a carnivore and was likely a fast, agile hunter, somewhat analogous to small predatory theropods, perhaps surprisingly for those who watched Walking with Dinosaurs. Another potential facultative or habitual bipedal carnivore was Postosuchus, with some paleontologists arguing that it was committed to bipedalism full-time, while others think it was more of a half-and-half kind of reptile, capable of both gaits. This evolution of bipedalism in some pseudoreuchian lineages may have granted these animals better vision by elevating the head in order to help find prey or food. Or its purpose could have purely been for more efficient locomotion in certain contexts. But that's not to say that the pseudoreuchians who remained quadrupedal were slowpokes. To some, they may come across as just big old lumbering crocodiles. But you have to remember that these apex predators were mainly terrestrial. Thus, they sported well-developed legs that were long and, more importantly, positioned directly beneath their bodies, rather than sticking out to the sides as we see in modern crocodilians. This allowed them to be rather efficient walkers and runners, with located tracks in Europe attributed to the Rauisuchian Tyrannosaurus, suggesting a speed of around 12 km/h while moving, which is a bit faster than a human's jog and fast enough to catch many Triassic animals. Here's the thing though, researchers also don't know if these tracks represented an animal in a full sprint or just fast walking. So it's very possible that even faster speeds were attained by some species. Additionally, in many Rauisuchians, the front limbs tended to be shorter and more lightly built than the hind limbs, even in the fully quadrupedal ones. This reiterates again that these carnivores were likely more agile and nimble than once thought, and not some clumsy lumbering land crocs. It was this combination of diverse locomotion, formidable size, powerful teeth, and often armor that made Rauisuchians and their close pseudoreuchian kin the true kings of many Triassic ecosystems, often ruling over the early dinosaurs. However, dinosaurs weren't always subjected to their rule in every single niche, partly because, as mentioned, true dinosaurs hadn't yet evolved in the very early Triassic. Currently, we think they first appeared around 203 million years ago, so about 16 million years after the first Rauisuchians. This was likely a big reason why the latter were so far ahead, evolutionarily at that time. Because as they say, first come, first served. Honestly though, when considering this, dinosaurs made some pretty remarkable headway within a relatively short period. Sauropodomorphs achieved remarkable sizes quite early on. And some theropods like Herrerasaurus and Gojirasaurus became quite big too, both measuring around 6 meters 20 feet in length during the late Triassic. Regardless, that still often wasn't enough to overthrow the largest contemporary Rauisuchians, with both of these dinosaurs coexisting with far larger adversaries, including the likes of Fasolasuchus in the case of Herrerasaurus's general environment. This power dynamic over dinosaurs is often clearly seen in fossil records from certain formations. Most of the time, dinosaurs only account for a small percentage of the total animal individuals within an environment, usually making up no more than 10% of the terrestrial vertebrate fauna, with the larger carnivorous dinosaurs being especially few and far between in these Rauisuchian-dominated ecosystems. On the flip side, smaller dinosaurs did fare a bit better, with one of the most successful early ones being Coelophysis, a speedy little theropod that was no heavier than an Australian cattle dog. It used its quickness to establish a niche typically not occupied by the giant pseudosuchian predators. Theropods and dinosaurs in general also appear to have capitalized on environments where large Rauisuchians tended to be less abundant. Even then, however, at least one or two pseudosuchian genera could often still be found who held the title of local apex predator. This seemingly endless presence of pseudosuchians was partly a side effect of the continents being arranged into the supercontinent Pangaea during the Triassic, leading to Rauisuchian-like forms being found on nearly every major landmass except Antarctica. Back then, the world was also different in most other ways too. For example, a good portion of Pangaea's interior was a vast super-desert. The odd river or lake within this vast dryness would have concentrated a good amount of prey for Rauisuchians and also showcased their prowess. Droughts happened to be extremely common, and when they would occur, Rauisuchian fossils sometimes became more abundant in certain depositional environments, which implies that they could easily dominate dwindling water sources and perhaps remain the last ones standing in harsh times. Some paleontologists further believe that certain Rauisuchians achieved this upper hand thanks to gregarious behavior, as a few genera are known to typically be found in groups. This is best seen in Dicuriasuchus, which was actually discovered in a remarkable grouping of 9 individuals. So with so much seemingly on their side, things really weren't looking that good for the early dinosaurs, and the future of terrestrial apex predation on Earth appeared to be set in stone in favor of the pseudosuchians. However, in an ironic twist of fate, something which would one day topple the dinosaurs' own long reign actually came in a way saved them from continued pseudosuchian dominance, a mass extinction event. Many people forget that the Mesozoic era experienced not one but 2 of the Big 5 mass die-offs, including the lesser-known Triassic-Jurassic extinction. Scientists believe that this event took place about 1.4 million years ago and had devastating impacts on life across the globe. The precise details are still a bit blurry, but the leading idea is that this catastrophe was primarily caused by the eruption of the Central Atlantic Magmatic Province, Camp Earth's largest continental igneous province, which covers an area greater than Canada. It's thought that this eruption, or technically series of eruptions, took place over a 600,000-year period and included 4 distinct pulses of intense volcanic activity. Together, these events are implicated in killing roughly 3/4 of all species on Earth, including a huge number of pseudosuchians. You can bet that the Rauisuchians did not escape lightly. It was in the midst of this doomsday event that every single one of their genera vanished from the fossil record, leading to a world temporarily void of many established top predators and opening the figurative doors wide for theropods and dinosaurs overall to diversify and rise to dominance. Now, why the Rauisuchians and many other pseudosuchians died out and the dinosaurs didn't, or at least survived in greater numbers and diversity, is another complex mystery not yet fully understood. Many ideas have been suggested, including that because some early dinosaurs were already found in or adapted to relatively cooler or higher latitude environments, they were perhaps better pre-adapted for the volcanic winter and climatic effects brought on by the massive eruptions. Others think the answer was a bit more plain, with dinosaurs simply having been faster at evolving certain key traits after the extinction, or that their smaller average body sizes at the time, or even just dumb luck, played a role. Whatever the case, it's obvious that dinosaurs emerged from this extinction event ready to take over, setting the stage for one of the most impressive dynasties of terrestrial life that Earth has ever seen. Thanks for your attention, and until next time, like this video and subscribe to Stoneborn, where every planet, every crater, and every fragment of dust tells the story of our beginning.